A rational inequality is an inequality containing a rational function. We'll solve these very similarly to polynomial inequalities. The only difference is that a rational function can change from positive to negative not only at x-intercepts, but also from one side of a vertical asymptote to another. Our steps for solving will be identical to what we've done for polynomial inequalities, except we'll also include vertical asymptotes on our number line. So example 3, solve and graph the solution set on a number line for x plus 1 over x plus 3 is greater than or equal to 2. So like a polynomial inequality, the first thing we want to do is get everything on the same side of the inequality, and we'll do that on this one by subtracting 2. Notice, though, that we have a fraction on the left-hand side, and in order to combine minus 2 with anything, we'd have to have a common denominator. Where we'll be solving using our calculators, we won't worry about having a common denominator on this problem. Okay? So from here, we want to proceed with now graphing on our calculator. Remember to use parentheses, so we should have parentheses around x plus 1 divided by parentheses around x plus 3, and then minus 2. Okay, and when you graph, you'll see something like this. Here we have our vertical asymptote. Okay, and if you look at our equation, x plus 3, if x is negative 3, that's 0. So this vertical asymptote we're seeing is negative 3. We also have one x-intercept right here, and we can find that either from the table or from calculating a 0. If we try the table first, we see at negative 5, y is 0. So there's our x-intercept. You'll also see in your table at negative 3, you have an error for y. There's another way to confirm what your vertical asymptote is. So we want to put negative 5 and negative 3 on our number lines. And looking at our graph, to the left of negative 3, the graph is below the x-axis. Between negative 5 and negative 3, that's this part of the graph right here, before we get to our vertical asymptote, the graph is above the x-axis. And past negative 3 to the right, that's this part of the graph, and that's below the x-axis, negative. Okay, looking at our inequality, we want to be greater than or equal to 0, so that's when the graph is positive. Okay, so from negative 5 to negative 3, okay, greater than or equal to, we'll start with a bracket at negative 5 to negative 3. Okay, and one final difference from polynomials is even though we have a greater than or equal to, remember that negative 3 came from the denominator of this rational function. And that means that we can't equal negative 3. So we would not want to use a bracket around negative 3 because that would indicate you can choose negative 3. If you chose negative 3, you'd divide by 0, and that does not exist. So bracket around negative 5 because of the equals, and parentheses at negative 3. Graphing this on a number line, we'd have a bracket at negative 5, parentheses at negative 3, and shaded in between.